So, two images here on the bottom. Two events I'm sure many of you will have seen this year. So let's start with a show of hands. Image on the right, that is the total solar eclipse from April 8th. Put your hand up if you saw totality this year. Okay. Put your hand up if you tried to see totality but didn't see totality. That's fantastic. That really is fantastic. Okay. And the image on the left, this was the famous May geomagnetic storm, G5. This is a photo I took down here in Colorado in Pawnee National Grasslands about 1 a.m. Who here saw the Northern Lights this last May? Okay, and how many people saw it from Colorado? And who traveled to like a different state? Okay, fantastic. So a lot of people saw both of these events. That's great. This is also a picture I took of the eclipse, but I've made it really small deliberately because it's horribly out of focus. And if I make the picture small enough, you can't tell. So that's why it's really small on the screen there. Cool. The final question I wanted to ask then before we get going, does anybody recognize the solar flare that is playing in the background and the significance of why I'm showing that right now? Let me show another movie of it on the next slide. September 10th, so it's today. Yes, so this is the September 10th, 2017 flare. So the 7-year anniversary of this solar flare. Really cool event. Positioned right here on the very edge of the sun. So we see this amazing, almost like two-dimensional standard model erupt with this plasma sheet moving out from the side. Also really beautiful to watch. And this flare with another flare that precursed it about 4 days earlier. So this is the 6th of September and the 10th of September. These were the two largest solar flares of the previous solar cycle. So solar cycle 24. Under the current sort of calibration, this is X13 on the left and an X11 on the right. Two magnitudes of solar flares that have yet to be topped in this solar cycle, which is interesting, right? We've had a bunch of really cool solar flares, a lot of sunspots, but this solar cycle has yet to top the magnitude of these solar flares. But another reason this solar flare is so interesting is this solar flare, the September 10th, so 7 years ago today, is the most published solar flare of all time. There are more publications on this flare than any other flare, even the 2014 events, any older events than that. And in part, this is due almost exclusively to the fact that every instrument was pointing at this flare. It was in the tail end of the solar cycle. There weren't really any other sunspots of interest on the sun at that time. This region had already produced X-class solar flares. So everyone was watching this flare. And so when it went off, all this amazing data. So this map is a map I put together 2 years ago, so it is out of date now. Every point on the map is an institution that is published or is listed on a publication of this flare. So here's another question. Who here in this room has been on a paper with this flare? Phil, you have. Data, you have. Okay, those are the two I knew were certain. So, okay, surprisingly few. Maybe there's not so many flare people here. But this flare was observed by instruments in space, IRIS, Hinode Ice. It was observed at Mars, Mars Express, MAVEN. There were solar storms at Mars that they published all really cool data. So again, a very exciting event for those reasons. But the flare also broke a bunch of other records as well. And not only is it the most published flare, it is also the fastest CME acceleration to ever be observed. So really a rapid event here. It's also the strongest gamma ray source, or strongest long duration gamma ray source. That's a gamma ray source that's been in the sky for more than 12 hours to ever been observed in astrophysics as well. So again, really cool for that reason. It's also got one of the fastest flux emergences ever observed and one of the fastest initial CME velocities as well, 4,300 kilometers per second. So a really, really rapid event. But the reason I sort of wanted to draw this parallel or talk about this is because this sunspot region, which produced these flares, AR 12673 is the image on the bottom just here, has a lot of similarities, at least in my opinion, to active region 13664, which is the famous active region from this May that caused that geomagnetic activity, which nearly everyone in this room thankfully saw earlier this year. The sizes are a bit different. This more recent active region is bigger. There were even a bunch of news stories which, although true, were sort of misinterpreted by the public. It caused a bit of panic. I saw some news stories saying this sunspot is a Carrington-sized sunspot. So the same sort of size as the Carrington sunspot region, which is true. But as we know, it's not just the size of a sunspot that determines its capability to produce very big flares. You need magnetic information, which is not covered in that statement, right? So then when official statements came out that there was a geomagnetic storm on the way, people had seen this earlier announcement of a Carrington-style sunspot and then this geomagnetic storm announcement. Some people online were panicking, and we'll talk a bit about that in a minute. But other similarities between the flares you can see here, looking in AIA 131. Active region on the left, the 2017 active region, produced 6 X-class solar flares in 6 days, so averaging about 1 a day, at least with the current classification. And on the right, the more recent active region produced 12 X-class flares in 6 days, so averaging 1 X-class flare every 12 hours, which at the time, to me, felt really unprecedented, right? That's a lot of solar flares. That's really great news if you're operating an instrument as a limited field of view, whether that be IRIS, ICE, ground-based telescopes. If for 3 days in a row, this region has produced 2 X-class flares, chances are, if you look long enough, you're going to capture some X-class flares, or at least some M-class flares. I know some space instruments specifically got some really great data from some of these events. The 2 most notable flares from this region back in May, one is the one on the left. This is the largest, I should say, strongest X-class to be observed this solar cycle so far. So clocking in at an X 8.8, which is kind of surprising because if you look at this flare, it looks relatively unexciting. It's the emissions coming from a very sort of small volume. There's no eruption, it's confined. There's nothing really interesting happening. If you look in stereo, which is just slightly ahead of us at the moment, it confirms that none of the sort of flare loops are occulted. So this X 8.8 is pretty much what that flare class was. But an event I think is more interesting is this one to happen the next day, clocked in only an X 3.5. So you might say, okay, not that large a flare in the grand scheme of things, but, oops, jumping ahead way too fast there. Sorry about that. So not too large in the grand scheme of things, but this flare is really occulted, very much so. You can see these very large super arcade downflows. These are high above the flare loops. The main arcade is kind of around the limb. And Solar Orbiter, which was behind the back of the sun at this time, that's a European Space Agency mission. It doesn't measure the same X-ray range as GOES, but it does measure hard X-rays. And in terms of hard X-rays, this flare produced about twice the magnitude of hard X-rays than this flare here. So this flare probably on the right was bigger than GOES, than the class measured by GOES in this flare. But of course, we can't confirm that because we don't have GOES measurements around the back of the sun. But that's a really interesting flare. I just wanted to highlight there. So I said that the activity from this region, right, AR 663, seemed unprecedented. To produce 12 X-class flares in 6 days, that seems wild, right? Has this happened before? At least has this happened before in recent times? Well, this plot on the left, this is showing the cumulative number of solar flares for both this solar cycle 25, versus solar cycle 24. The red, yellow, and blue show X, M, and C-class flares respectively. The thin lines are the previous solar cycle, the thick lines are this solar cycle. And you can see, I think this was updated at the 1st of July or something. You can see this massive jump in X-class flares that we experienced this May. Prior to that, even though the sunspot numbers were much higher, X-class flares were lower than the previous solar cycle up until this event, or up until this active region, even though the M and C-class flares, there were a lot more this cycle. But you can look up here and say, okay, the previous solar cycle had a similar jump, right? This is August, September 2014. There were a bunch of solar flares. This looks like a similar number of X-class flares here. But at the time, these were not reported as such. So if you go back and sort of look at the operational data, so the class of these flares as they were announced at the time, the graph here looks very different. And the reason for that is the NOAA recalibration, which I'll discuss briefly on the next page. But if we look at the operational data, so if you just look at how these were reported at the time, it looks like this solar cycle has already overtaken the number of solar flares from the previous solar cycle. The 2017 September events, there are just 3 X-class flares here instead of 6 X-class flares here. So something is very different between these two graphs. And the reason for this difference is something that I feel is underknown in our community. I think a lot of people know about this, but I think in terms of scientific analysis, I think scientists who aren't working in operations maybe aren't familiar with this. But in 2020, there was a recalibration or a correction to a calibration to all NOAA flare data from 2010 to 2020. So essentially, 2020, the new GOES instrument launched. There was a slight mismatch in the calibration levels. Data within this period had sort of been calibrated incorrect. So they corrected that data, and it changed the flare levels quite significantly. So these September 2017 events that I showed you went from an X9 and an X8 to an X13 and an X11. So were only reported at the time as X8s and 9s. And similarly, the recent events that we had, X8 and X3.5, would have only been an X2 and an X6 if they had been reported in the previous solar cycle. So this does sort of change the way that we think. So this event we had recently in May, it seems like there's a lot of X-class flares happening, 12 and 6 days. That's because the previous solar cycle, there were 6 X-class flares, but at the time, we didn't know it. It was an undercounting there, if you will. But why does this matter? Well, as I'm going to convince you in the next few slides, solar activity, when solar flares happen, correlate very, very well to public interest in these things. So here's just an example, and I'll show you a few cases of this over the next few slides. This is Google search trends. You can search anything you want. You can compare, I don't know, ducks to chickens, and you can see how people Google these over time, and you can see the trends from Google's inception. This is the Google search trend of northern lights in green, southern lights in purple. These are both normalized to the maximum of the individual search peak. Northern lights normally has many, many more searches, but it's been normalized. This shows a percentage of the highest month, and we go from March 2004 all the way up to September 2024, so the first sort of third of this month. And you can see some really nice patterns here, ignoring this peak on the end. You can see this sort of annual sort of cycle of people Googling northern lights and southern lights in the winter and Googling it less in the summer. Now that's interesting because, of course, the southern lights don't happen in northern winter, they happen in northern summer. But if you sort of jump into the statistics, there's a population imbalance, right? And more people are actually Googling southern lights in the northern hemisphere than they are in the southern hemisphere. That's why we sort of see this sort of spike happening in the winter. But this is really cool, right? All the way on the very end, this is May 2024. The search term northern lights was Googled 8 times more in May than any other month on Google's record. 8 times. It's nearly an order of magnitude spike of people Googling the northern lights. And this, of course, is due to the G5 geomagnetic storm. Everyone was seeing it on social media. They were seeing the news. They were going outside, seeing it for themselves. And almost immediately, as soon as it was over, people stopped caring, stopped Googling it again. And this is a pattern that you'll see in some of these next slides. So here's a little bit of audience participation. I've got 7 terms here and maybe about 4 graphs. Let's see if we can work out together what search term am I showing the plot for here. This is an easy one, right? We've got a spike in August 2017, a spike in April 2024. Solar eclipses, yes. This is the search term, for solar eclipse. And there are some interesting things here on its own, right? This is worldwide. So this is worldwide searches, but you can see the 2 American eclipses and even the October annular eclipse are the 3 biggest peaks. This is the April 2023 eclipse, which is visible from a very small part of Australia. Not many people Googling this, but these are all other small eclipses that have occurred, or not small eclipses, but small searches for eclipses that have occurred over the last 20 years or so. And what I find interesting, and I have no idea why this is, but the 2017 eclipse, despite the path of the eclipse going over a smaller population than the 2024 eclipse, which had more people in the path of the eclipse, this eclipse was searched for less. So this eclipse was Googled less by the public than the 2017 eclipse. Why that is, I don't know. Maybe people had fatigue from the previous eclipse. Maybe they think they happen all the time. I don't know. But for whatever reason, that's pretty interesting there. What about this next one? This one's a bit harder. So we have some spikes here, 2011, 2012. We have 2014, a few spikes, and another big spike here in May 2024. There are 2 terms that are quite closely related. Anyone want to give it a punt? It's not the CME, very close. This is solar storm and geomagnetic storm. Now, this is, again, I think very interesting. There's lots to unpack here that I'm not going to go into. but these all correspond to sort of news reportings of geomagnetic storms, auroras here on Earth. But, oops, let's just go back there. But what I find really fascinating is back in the previous solar cycle, everybody was Googling solar storms, which, you know, is sort of a colloquial term, doesn't really have a very specific definition scientifically, whereas this most recent event, everyone is Googling geomagnetic storm. So clearly there's been a shift in either the way things are being presented by experts or the way the news and the media are reporting this, but there's been a shift of reporting from using the term solar storm to the more specific geomagnetic storm, which I think in itself is pretty cool. This next one, there's not many left. I'll just go through this. This is CMEs and solar flares, coronal mass ejection solar flares. You can see the bit of a spike here this year in May, but not Googled as much as it was back at the height of the previous solar cycle. And these are all very famous flares. If any of you have published on X-class solar flares, you can probably see your flare on here somewhere. Here's a September 2017 event, for example, there. This one, again, this is space weather. So this one does not drop to zero like the others do. So this one is being Googled continuously. People are always interested in space weather. And you can see there is still some cyclical variation here. And this last one, this is pretty dark, actually. This is the search for aurora. So there's a bit of a variation here. You can see maybe sort of annually, maybe not quite. The problem with the search term aurora is there's more than one use for the word aurora, right? This is the May 2024 aurora that a lot of people saw. There's also a musician called Aurora. There's Aurora down in Colorado, not far from here. So this spike, unfortunately, is not related to the Northern Lights. This is related to the shooting in Aurora back in 2012. So that's that spike. So for the first time, and I guess this is somewhat positive, the maximum search for aurora was overtaken in May, overtaking the previous peak, which was not due to space, but due to not good things. So why am I telling you this? Well, long story short, I was sort of inspired to look at these trends based on this sort of comic I saw on Twitter, and I wanted to see if this was true. The comic says Google Trends search for solar flare actually follows the solar cycle. And when you take the data that I was shown, a colleague of mine took the plots and actually made sort of the rolling average, and they've clearly they did the calculations here. This is true. So the Google people searching solar flares literally follows the solar cycle. So this is the solar cycle happening not in nature. This is the solar cycle of human search activity and the cycle of human interest in what we do. So this is one of the lessons that I'm going to try and convey over the course of this is right now, the public are relatively interested in the sun. The sun is doing things. The sun is making the news, as I'll show in the next couple of slides. So this is the time to get the messages out about things you want to get the messages out about, because soon we're going to lose public interest, and it will be the solar minimum of public caring about what we do, right? Also interesting, no idea why, the solar cycle of public interest has a peak about 2 years prior to the actual solar cycle peak. Why that is, I don't know. Okay, but as you saw, a lot of the peaks there, a lot of the search trends related to the May 2024 geomagnetic storm. Now, there's a few of us from NSO here. This solar storm was pretty cool for one reason, and that being the time of the solar flare, we had a welcome event for Christoph, actually. There you go, Christoph. We had a welcome event for Christoph. Isla set up the telescope that we took to the eclipse on the balcony. We had some drinks, some snacks. It was a fun time. And whilst we were looking at the sun, I got an alert on my phone saying there was a solar flare in progress, and everyone rushed to look, and we could see these bright ribbons slowly separating over the course of the hour or so. It reached X1, X2, and that was the solar flare that 2 days later, we all went outside and saw the aurora. So we literally saw both ends of that process, which was a nice way of the sun welcoming Christoph to Boulder, I suppose. These are some photos I took in Pawnee National Grasslands. We had the aurora directly over our head, which is really fantastic, really cool stuff. But it wasn't just us that cared about this. This made headlines all over the world. UK, Europe, here, South America, South Africa, Australia. This aurora was really seen over a lot of the world because we had multiple sort of CMEs in succession. It was really long-lived too. And another question I want to ask is, who here, either for this event or the eclipse or a previous solar flare, who's had like a press inquiry and like given a quote to like an article or something. Okay, maybe like 20%. I'm sure more people haven't put their hands up. I think, again, if the press approach you, and this is something I encourage students and other fellow early career people to do, get on social media, post about this stuff when it happens, and eventually the press will contact you for quotes. And my advice is this is the opportunity when you're giving these quotes, don't just be rigorous and just say, one line what's going on. This is your opportunity to connect the public to wider things of interest. If you have a mission that you're trying to get funded, say, it's really important that we have this kind of thing in the future, or, it's really great to do this sort of work. Like, they will include those in the quotes, and you can use this stuff when applying for grants or whatever. I think it's just really good experience for everyone to do. And this is another thing, another mistake I feel people make is when they do outreach and when they do press inquiries, people get, I think, too hung up on the Carrington event. People say, it's important to understand these things. It's important to understand space weather because the Carrington event could happen, right? But as I've sort of discussed by the NOAA talk this morning, people care more than just the Carrington event. It doesn't need to be Carrington for people to care. This is a headline from May this year about astronauts not being allowed to move around the space station due to the radiation from the geomagnetic storm. This is from February 2022. 40 SpaceX satellites didn't make it into orbit. And, these are small things, or relatively small, that don't necessarily make national headlines, but these happen fairly often. And I think we should use more of these case studies to sort of highlight in public talks why this stuff matters, rather than just this abstract thing of the Carrington event that happened all this long time ago. Could happen and will happen, right? It's important, you can mention it, but don't weigh your whole argument just on one event that might not happen for another 100 years. But sometimes media get things wrong. I wish I had, this was a really weird day. This is February 2024. I woke up, checked Twitter, and all these news outlets, like proper news outlets, and I didn't get any screenshots early in the day, I wish I did, reporting that a solar flare had caused a bunch of AT&T towers to go down, to go offline. And if you're a solar physicist, you sort of think about this for a while. It doesn't make any sense why it's not the right wavelengths. Why would it just affect one network? Like, it didn't fit together, but this was being widely reported by mainstream media. And thankfully, it was only a couple of hours before sort of experts got involved and they corrected these headlines. But for a couple of hours, headlines were up saying the solar flare had caused these. And I tried to trace back the origin, and it came from a weatherman from a local Fox station in Florida. Had just said, we have these AT&T outages. There was also a solar flare last night. These might be related. And this was picked up by someone else, until major headlines were stating this. So again, media, they pick up on a lot of stuff. That's great. But sometimes they get things wrong and rely on people to correct them, right? And that brings me to social media. Social media can be a bit depressing. I'll be honest. Who here has like a presence on social media where they post about their work? Or very few. Okay, a few. Social media, I think, especially recently, is not always a fun place. Twitter, now X, I think has changed quite a lot in the last year for whatever reason. So I think there are good aspects of social media and bad aspects. Some great aspects, and this is whether you're doing outreach as an institution or if you're doing outreach as like an individual, public awareness of space missions, exposure to when these events are happening, right? Aurora eclipses. It provides, when you post pre-pictures of the sun, I think it provides like insight to people who don't realize the sun is a star and does this cool things, increases this exposure to astronomy, that directs them directly to results, scientific work, all these fun things, right? But for every sort of scientific institute, for every NASA, NOAA, NSO there are 100 conspiracy accounts. And it really is exhausting sifting through some of these stuff. Some of the stuff I've come across, some of these accounts have tens of thousands, hundreds of thousands of followers, and it really winds me up. And these are different conspiracies. You think they'd be friends with each other, but they're fundamentally incompatible. Some people think the sun's going to kill us all. New Carrington, they're going to build a bunker in their back garden. there was a very prominent YouTube account. This account has 1 million followers. I'm not going to say the name, but 1 million subscribers on YouTube. They did a video on the May geomagnetic storm, and they said in their video there was an 11% chance of it killing everyone. And this video had millions of views, like really crazy stuff. Some people use the sun to sort of fuel climate change denialism. I think this was a very popular theme back in the 70s and 80s, when sort of solar activity was sort of trending in the direction of temperatures. That sort of went away for a while, but honestly, with this solar cycle, I've seen this resurgence of people saying, oh, it's not climate change, or it's not fossil fuels, it's the sun. And obviously the science is very nuanced. The sun plays some minor role, but whatever. People saying fossil fuels, not doing anything, it's all the sun. And some people, just like they've been saying the moon landings are fake for decades, some people say every image they see of the sun is fake, even ones that come from amateur astronomers in HAB from their back. Honestly, crazy stuff. But these content is getting a lot of engagement, which is a problem. So I guess my encouragement is social media needs more of the good and less of the bad. So as I recommended to early career researchers and PhD students, if you get on social media, press will contact you. But I think it's also important that we have sane voices talking about these things, seeing these things, calling out these things. And this is especially relevant. I'm going to call out TikTok, right? TikTok, for whatever reason, federally funded organizations are not allowed on TikTok. So there's no NASA, there's no NOAA, there's no NSO, there's no official outreach on TikTok, which just allows the absence of that voice to really spread to a load of crap on that, to be honest. But so if anyone wants to go on TikTok, I admire you. I think it's important that SciComm be done there too. And here's a case study of that. So I sometimes post on TikTok, not very often these days, but this is a little case study, I think, of how social media can be useful for sort of learning best practices, improving your outreach work. So I posted a video, I think November last year. I did pretty well, got close to a million views, had a few thousand comments, and basically talking about the upcoming eclipse. There was a couple of eclipses recently in the US, but don't let that fatigue you. This is a really rare event. You should all go out and see this. And an unexpected consequence of this is I had hundreds of testimonies of people commenting what they thought about the previous eclipse. And this sort of feedback, hundreds of people telling you, their misnomers, what they incorrectly think about eclipses, what they like about eclipses. I thought this was really valuable for planning this outreach stuff. Here are just a few quotes. For every insightful comment, magical, surreal, unworldly, life-changing, you also get, cool, dope, sick. So a wide range of a wide range of articulation in these comments, but a few things that are quite moving to me. There are stories of people saying they got proposed on the previous eclipse, memories of parents who they saw the eclipse of who are no longer around. One story I thought was really strange. There was a woman saying she was in prison at the time of the eclipse in 2017, and they didn't let them go outside and look at it. So they were inside the whole time, and it went straight over their heads, and they didn't see it. So I thought that was pretty sad. But as I said, content like this and interacting with the public directly gives you a window into the sort of data collection I think NASA, NOAA, NSO really struggled to get. And this is first-hand accounts of misnomers and subjects for outreach targeting, things like that. And if you're interested in this, I did actually write a short article in the bulletins of the AAS. They had a special issue on the eclipse outreach. So I did do a short explanation of that work here. But, eclipses, enthusiasm in eclipses, this is not a new thing. This is the 2017 eclipse, I believe, in LA. This is an eclipse in Germany in 1907 or something. People have always been interested in eclipses. There will always be many people wanting to come along and listen to you talk about eclipses. And this is well reflected, and this is quite a cool graph. This is showing the percentage of Airbnb occupancy in the days leading to the eclipse. So we'll start again, September, August 2nd. You see the weekend gets a bit of an increase everywhere. And then you can really clearly see the path of totality along this map of Airbnb rentals. So people will travel, although apparently not Google it as much as they did in 2017, millions still traveled for this event. Us at NSO, we had a fantastic presence for the eclipse. Each of these stars is the location of someone at NSO at the time of totality. Down at the bottom here, this is down in Mazatlan. We had Sanjay, Gianna, Kenny. They had probably the best view of any of us. I think this was in between iguanas coming and snapping at their legs or something like that. But fantastic, beautiful view down there. Up at Eagle Pass at the border to Texas, we did a large outreach effort at a stadium down there, visited a few schools, Masha, Marcel, Evan, John. And this was sort of a multi-location effort. We planned a NSF live stream. We live streamed the eclipse and sort of mingled it with this sort of documentary. So I was down here in Dallas. That's me presenting. We had the telescopes for reasons I will explain up here in Illinois, and Jorge, our Director of Education Public Outreach, was in DC in the NSF studio. This was a really good fun. This is available online. Anyone wants to watch this. We had up in Arkansas, Alin, who's at NSO, and a few HEO people as well. I think Momo's up there, Daniela. We're here in Arkansas. And then finally, Kevin's group was also doing science up here too. Unfortunately, as many of you might have experienced, although the path of totality looked like this, in the days leading up to the event, the weather looked like this. This almost looks like a joke, right? Like the whole country is mostly clear, except this long band of gray cloud spanning almost directly up the path of totality, which was a bit of a stress. And this is almost directly inverted to the sort of the predictions based on historic data, where you expect really clear skies down here and maybe cloud up here. It was the complete opposite, really clear up here and really cloudy down here. So everyone had made plans, they're in the wrong place. And this is reflected quite well. I'll just flick through this really quickly. This is the movements of all the NSO teams in the days prior to the event. We all started up here in Boulder with a few remote staff. We click through, everyone starts traveling, fantastic. Everyone's here pretty comfortable, fantastic. And then I think it's the next day, everyone sees that forecast, and then this happens. Everyone is fleeing up the path of totality to get away. Most of us were pretty happy, except Alin's group. They discovered they actually left a crucial part of their telescope here in Boulder. There you go. He's proud of it. Look. So they phoned up a student who they had drive from here to meet at this location, to then drive back a few hours before the eclipse to get back and set up their telescope with not a lot of time. So I'm sure Alin will be happy to talk more about that if you ask him. But everyone succeeded, which is the moral of the story. We all saw the eclipse. People got data. We managed to reach the public with this stuff. So really, really fantastic. But as bad as some of these eclipse expeditions were, sort of the last story I want to tell here, as bad as these eclipse expeditions were, they weren't as bad as this guy. Let me tell you this story. He's a French astronomer, as you can probably tell from the name, born 1725, who's part of the Royal Academy of Sciences in France. He wanted to see not an eclipse, but a transit of Mercury. Who here saw a transit of Mercury in 2004 or 2012? A few of you. Cool. Sorry, transit of Venus, 2012. Transit of Venus, yeah. Sorry, transit of Venus, he went to see. The transit of Venus was visible from the sort of South Indian Ocean. So he traveled all the way there, which took about a year and a half. And by the time he got there, there was a war going on between sort of the French, the British, the Spanish were involved. This was in this sort of the Indian Ocean. He couldn't get to shore on the day of the transit. So he was stuck on a rocking boat, could not take measurements of the transit of Venus. So he failed, unfortunately. But it wasn't so bad, because 8 years later, there was another transit of Venus. They'd come in pairs and they're separated by about 100 years or so. So he thought, okay, I'll write back home to my family, I'll write back to the academy, tell them I plan to stay here for 8 more years. There's like a lunar eclipse. I'll see this. It'll be fantastic. I'll get this amazing data. I'll build an observatory. I'll be ready. Cloudy. It was cloudy, 1769. So unfortunately, he did not see the eclipse. So he thought, that's a shame. I'll head home. Too bad. The way home, they were sort of not shipwrecked, but there were a lot of disease on the ship. They had to pull over. They had to dock for a couple of years. It took a long time to get home, like 2.5 years. And by the time he got home, he had this horrific realization that due to the war, France, Britain, Spain, none of the letters he'd sent to his family or the institution over the 8 years, none of them got home. So this is a direct quote. He finally arrived in Paris in 1771, having been away for 11 years, only to find out he'd been declared legally dead and replaced in the Royal Academy of Sciences. Continue. His wife had remarried and his relatives had enthusiastically plundered his estate. So if you've ever had a bad eclipse expedition, at least it wasn't as bad as this guy, right? It can always be worse. The next eclipse, as you may know, coming up August 12th, 2026. It's the day before my birthday. I'm going to have a big birthday party. You're all invited. Following that eclipse actually isn't going to be great. It's only about a minute long. It's near sunset, low on the horizon, a lot of cloud up here. But the one to really look out for is the year after, 2027. Going straight through here, 6 minutes long. And some of these locations have near 100% chance of sunshine. So this would be the next sort of really cool eclipse. Spain, as you saw, is getting a series of eclipses. It's getting a totality in 26 and 27 and an annular in 28. Portugal, unfortunately, missing out on totality all 3 times. I guess this is an annular. But Spain's run is not as good as Australia's run. Australia is getting an amazing 4 total eclipses in 10 years, between 28 and 38, 4 eclipses, plus the one they just had last year in 2023. And these go through big cities as well, Brisbane, Sydney, Melbourne, or close to Melbourne. The next American eclipse, pretty hard to get to, 2033. I don't know how many people live under the path of totality there. I would guess not very many. This is the very north of Alaska. So for all intents and purposes, the next mainland US eclipse is 2044, just way up here through Montana, North Dakota. But in 2045, maybe some of us will still be working here in 2045, there is an eclipse passing right over here, pretty much. We are about 10, 20 miles away from totality. So this is 2045. I'm sure a lot of young researchers here, hopefully including myself, will still be in the field at that time. So keep that in mind, 2045. I mentioned the transit of Venus. When's the next transit of Venus? Forget it. The next transit of Venus is 2117. So I think very unlikely any of us will be around in 2117. Actually, is Teddy over there still? Teddy, give us a wave. There we go. Teddy, I'm told, was born in 2018. So well, hopefully you will be there to watch it for all of us and think of us when you see this transit of Venus in 2117. That's the end of my talk. Conclusions, auroras, solar eclipses, they definitely capture public attention, turn the public's eye on us, but the attention is fleeting and short-lived, right? I think, and this is just my opinion, maybe you might disagree, I think solar physicists should take advantage of this attention. If you get media inquiries through social media, do highlight missions, science, recent work, all that fun stuff. Social media is useful for a lot of reasons, but it's full of misinformation. So I, again, think the presence of experts on that platform is critical. Again, just my opinion. And finally, the next few years of SolarMax will provide plenty of opportunity for all of these things before people forget about the sun for another solar cycle. That's the end of my talk. I welcome thoughts, questions, comments at happy hour. Thank you for your attention.